Prevention and rehabilitation fix the cause, not the symptom. Imagine visiting two buildings with identical cracks. At first glance, they look exactly the same. The maintenance team repairs both using the same repair mortar. One building performs perfectly for another 15 years. The other begins cracking again within 6 months. What went wrong? The repair was not the problem, the diagnosis was. This is one of the biggest misconceptions in construction. People repair what they see instead of understanding why it happened. A crack is not the disease, it's a symptom. The real cause could be corrosion, foundation settlement, poor quality concrete, thermal movement, excessive loading, chemical attack, or even poor workmanship during construction. Unless that root cause is identified, every repair becomes temporary. Think about visiting a doctor. If you have a fever, you don't simply reduce your temperature and assume you are cured. A good doctor investigates the infection causing the fever. Engineering follows the same principle. Modern rehabilitation always begins with diagnosis. That's why experienced engineers start with detailed inspections. Visual assessments identify surface distress. Non destructive testing, commonly known as NDT, helps evaluate internal concrete quality without damaging the structure. Methods like rebound hammer estimate surface hardness. Ultrasonic pulse velocity identifies internal voids and cracks. Cover meter locate reinforcement. Half shell potential testing helps assess corrosion activity. These technologies allow engineers to understand the structure before recommending repairs. Only after diagnosis do rehabilitation strategies begin. Sometimes the solution is as simple as sealing surface cracks. In other cases, deteriorated concrete must be removed and replaced. Corroded reinforcement may require treatment or strengthening. Carbon fiber wrapping may be needed to increase load capacity. Cathodic protection systems can prevent future corrosion in aggressive environments. Notice something important. Every successful repair is different because every failure has a different cause. There is no universal repair solution. That's why experienced engineering judgment is far more valuable than expensive repair products. Did you know many rehabilitation projects fail because the visible damage was repaired, but the underlying deterioration mechanism continued unchecked? The result, same defect reappears, often faster than before. Practical takeaway: never ask, how do we repair this? First, ask, why did this happen? The quality of the diagnosis determines the quality of the solution. Viewer engagement. If you discovered cracks in a building, would you repair them immediately or investigate the cause first? Tell us how you would approach it. Transition. Understanding repairs is important, but the most successful projects don't depend on repairs, they depend on prevention. And prevention starts long before concrete is poured. Conclusion: building for generations. When people admire a great structure, they often praise its beauty, its height, its architecture, its innovation. But the true success of any structure is measured by something much simpler. Does it continue serving people safely year after year, generation after generation? That's the purpose of engineering. Throughout this episode, we have seen that concrete itself is not the problem. Poor decisions are: adding too much water, skipping curing, ignoring quality tests, poor workmanship, weak supervision, delayed maintenance, each shortcut seems small. Each shortcut seems small, but together they determine whether a structure lasts 20 years or 100. The encouraging news is this: almost every major concrete failure we have discussed today is preventable, though better engineering, better planning, better quality systems. Almost every major concrete failure we have discussed today is preventable through better engineering, better planning, better quality systems, and a commitment to do the right thing even when nobody is watching. Because quality is not something inspectors add at the end, it's built into every decision from the very beginning. Whether you are designing a high rise, constructing a warehouse, managing infrastructure, or building your own home, remember this: concrete does not simply support structures, it supports families, businesses, communities, and economies. The quality decisions you make today will become someone else to safety tomorrow. That's the responsibility every engineer carries, and it's a responsibility worth taking seriously. Final call to action. If you found today's discussion valuable, let us know in the comments what's the biggest concrete quality issue you have encountered on your projects. Your experience could help someone else avoid an expensive mistake. If you are involved in construction, structural engineering, project management, or infrastructure development, subscribe to SunXBuild. Every week, we share practical engineering knowledge that helps you build safer, smarter, and more profitable projects. If your organization needs support with structural design reviews, independent engineering verification, project management consultancy, QA/QC audits, structural health assessments, non-destructive testing, quantity estimation, engineering training, our consultation link is available in the description below. Because the best time to solve an engineering problem is before construction begins. Until next time, build smart, build safe, build with SunXBuild.